Hello, and hi there, and welcome back to another episode of Classic Arcade Repairs. I hope you like the new camera view. I got me a little boom type camera holder. I am getting set to work on another gunfight PCB set, and I actually got this one. It's Thursday today. I got this one out on Monday, and I haven't done anything in a few days because I have not felt good at all. So, I'm just getting out and sitting down to look at this thing. This is a very old, early looking board. If you can tell, it does have. Let me come back a little bit. There we go. It does have the good. And I did inspect this a little bit. This connector here is fine. We have a bad socket. That's got to go. This socket has to go. It looks like these have been replaced at some time in the past. These sockets here. So these sockets are going to go. And I'm going to check this. It looks like there was a broken trace here due to some work. So we're going to clean this thing up really good. This socket has got to go. It had the this 8080 inside of it, and you can see it's got broken legs. It's got broken legs all over it. So that thing is no good. You know. And the EPROMs, it had two EPROMs in it. These EPROMs are no good. And I just pulled this chip out of that socket. It's, yeah, I mean, it's good. It's not broken or anything like that, but these chips, these chips are no good. They gotta go. So we need to do some cleanup first thing. And here is the other board. Excuse me. Here's the other board, and we do have some bad sockets all over this place. These sockets are gonna go. The sockets underneath the amp, I'll probably replace those. It's got those white sockets under the amp. The connector looks good. Just clean up a little bit. Yeah. All in all, it's not terrible looking. Not too bad. What the hell is that? Oh. This? Let's look at that. That is not going to work. I don't think that's a... I'm going to put my meter in ohms mode. And this guy right here looks like it's just a resistor pack. Resistor array. And it says... What does it say on it? 620? Is that 620? That's 2K. That's 2K. That is 2K. 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 Okay. Is this just a 2K resistor pack? Well, no, there's 1K. So I don't know what. Here's 1. 2K. I don't know what this is. That's going to have to be replaced. That's supposed to be a 560 ohm resistor network. Or a 1K. You can put 1K resistor network in there. That's not what this is, I don't believe. This should be pin 1. Okay, there's 1K. There's 1K. 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 1K, and okay, that is 1K. That is not a just through resistor from this side to this side. This is actually a dual resistor pack, I believe. And it's a 1K on both sides. Watch, you'll probably get 1K from here to here. 2K. Is that 2K? Or is it 1K all the way around? Yeah, it's going to be 1K all the way around. So it's a bunch of 1Ks. It's, what, 14 1K resistors? Or 15. Oh, whatever. Okay, I get it. Okay, yeah. It's just a bunch of 1Ks. So that's actually fine. That can stay. So the first thing we're going to do is do maintenance on this board. This board needs to be dealt with right here. So I'm going to go ahead, remove these sockets, clean this board up, and resocket it, recap. We can go ahead and test shorts to ground. So if I put my red probe lead on a ground pad, okay, if I can find a ground. And is that grounded? Can't tell. That's ground, I think. Yeah, that's ground. So let's look and see if any of our voltage rails are grounded. Is this ground? No. And plus 12, I believe, is this. Where is ground? Where is ground, actually? Is that up here? Yeah, that's right there. That is ground. So we do not have any ground shorts. I believe this is 5 volts right here. Negative 5 is up here. And plus 12 is right here. Yeah. That's 12. Negative 5. And plus 5. So there's no shorts to ground, so we're good to go ahead and move forward. We're not grounded, we're not shorted out, so you want to check that on these kinds of boards, because these tantalums will often blow out to ground and you'll have a voltage rail shorted to ground. So good. Go ahead and do some maintenance, remove some stuff, clean up, and here's our crystal. That's nice. These are Texas Instrument RAM, which is good, but the bad thing about Texas Instrument RAM is they rust and tarnish. The legs are silver plated legs. So what I'm going to do after I clean this is I'm going to pour some Tarnex right over these chips, and I'm going to brush it with a toothbrush until they come clean, and then I'm going to rinse it and wash it again. That'll shine those up and get that tarnish off of those legs. These are so kind of rusty and bad that it might just eat right through the legs. I don't know. If that's the case, then they have to be replaced. We'll find out when we get there. But I'm going to have to look at the strapping. The strapping has to be done for 2716 EPROMs. Yeah, so. All right. Well, we'll get to that. I'm going to get to doing my cleanup. Oh, sorry about the little shaking there. I kind of hit the little boom thing. I really dig this. I like doing this. I can actually just work with this out of my way. Okay. I'm just going to kind of let it record what I'm doing. I pulled the black tops off of here. And we have, let me check this out really quick. Yeah, it's not terrible. Okay. So I'm going to go ahead and line this with flux. And I'm going to go ahead and squeeze some in here. You know what I need to do is first, let's remove this. Oh, where is that? Okay. Whenever you see sockets like this, they gotta go. Straight to the trash. Now you can get in here now. And just put a line of flux down there. Both sides. There we go. So we've got that. This thing, I'm just going to put a line down through here. Down through here. And the idea is to get that to activate as you're desoldering so that it mixes in and helps that desolder. Alright. So next thing I'm going to do is I'm going to bring my glass down. And I want to make sure that these legs are straight. Okay, looks good. All right. All right. Okay. Now normally I would do the old pick the pins out method, but since this has been done at some point, and I still might have to do that, you still might have to pick them out because you don't want to force anything out. But since these were resoldered and the solder's really kind of nice, I figured I could just get away with desoldering them and them falling out. But if they don't fall out, then I will have to heat from the top side and pull them out. You don't want to force anything. just give them a little wiggle, and normally they'll break free and come out. If they don't force them. That's it. And let's take a look. And I do want to just try to remove this. Yeah, that broken trace right there. I'll remove that. I'll just fix that myself. Okay, let's throw away the garbage. The garbage. And then we get to do this wonderful thing. Piece of junk. So we'll do that. Another good thing about using that flux like that on the other side, it keeps your gun really good and clean. It's a little smoky, but it really keeps your desoldering gun clean. Bring this old board back to life. Wonder when the last time this baby's worked. And let's see how loose that is up here. These should come right out. But you can just kind of side to side and twist it, and it comes right out. See that flux just does wonders. It comes right out just like that. Nice, nice, nice. Now we're going to remove that guy. So we'll flip it back over. That one is right here, so I need the mirror, or I need the magnifier, and I got to straighten the legs. You want the legs to be as straight as they can be. There we go. Put this back up. Clean the gun. Clean the tip. And get back at it. This guy right here. Leave this on here just long enough. You don't want to pull pads, but you want that flux to activate on the other side. Okay? Keep your gun clean. And that should come right out. Just give it a couple twists. A little shake, a little twist, and right out. So now we've got all the garbage sockets removed off of this board. This board needs to be cleaned, and then we're going to, after we clean this, we're going to come back through with more of that flux, and we're going to make sure that we get some of that flux. I'm going to put some, just put some in the area, and I'll put a glove on and just kind of rub it into the through holes, because you want some of that flux in that through hole. So now that we've done all of that, now we need to just clean. Now we can clean. But you know what we can do right now is, since I got my desoldering gun out, we'll move on to this board. And 74 these are the 82S chips, and then there's the amp. So I'm going to remove, because these sockets suck. They really do. You know, you need to replace these. And this chip's got a broken, no, it's just it's a bent leg. It's not broke. There we go. It was just bent. I'll fix these legs a little bit. Okay. Very good. And I'm going to start a little parts jar. That's where we're keeping our parts. We're going to remove this amp heat sink. I'm surprised that nut isn't spinning. Nice. I got lucky. There is a nut on the opposite side of this, and they are not spinning for whatever reason. These have the little heatsink things on them. Interesting. These amps have the heat sinks on the amps themselves. They don't all have this. You see this? How these amps have this little, they have this heat sink on them. It's pretty cool. Okay, nice. Put those in the jar, in the little parts thing, along with all this. No heatsink transfer paste at all. I don't really like that. We'll put some heatsink paste on there to get a good heat transfer. I'm actually not crazy about these having to thread through the heatsink, or having to thread through the heatsink that's on the chips themselves, because it's kind of overkill because they're being fastened from the other side. You know, I don't really care for that. I kind of wish those were just through holes. I'm not going to drill them out. I'm just going to do it the way it is, but I don't care for that. It's overkill. Okay, good. So, same thing, we'll apply our flux along these. Okay. Very good. And now we bring this down. I got to make sure these legs are all as straight as they can be. Cracked solder joints. There's bad solder joints on this. I can see them from here. I don't even need the microscope. Okay, that should be good. We'll do these ones first. That one's already out. Fell right out. I think I hear my cat. That one fell right out too. Yeah, I think I hear Boo Boo. There. Those are out. I'm going to go let my cat in. Oh, I can hear her out there bitching. She's been very vocal, yelling a lot lately. Maybe not. I thought I heard her. I guess I didn't. Okay. Those two junk sockets are done. Yeah, when it comes to these kind of sockets too, you never know if these things even, the legs are even broken through the through hole. So I'm just going to make sure that the legs are straight. Yeah, you run across these sockets, they need to be replaced. And then let's straighten these four up. I hate it when they bend. You get legs that are bent over. I hate that. What you really need to do is do that and then do the other side. Like this. And then there's one more, which is right there. That one's already good. Okay, so okay, it's right here, right there. Remove that guy. Just kind of back and forth a little bit. Give it enough time for that flux on the back side there, the top side actually. Let that flux activate and it'll mix in with that. And I mean, you get a really good pull. It doesn't matter how old this solder is, you can really get it out. There's just a technique to it, to not destroying your boards. That fell right out. You know. Yeah. Fell right out of the board. And now we got these 4 over here to do. Just 4 more. Alright, let's see how these do. That one's out, but this one needs a little bit of a tweak to get out. No big deal. And let's go ahead and clean up our gun. Still just nice and clear. That broke. That leg broke, I guess, when I straightened it. And let's see how we did. That's that. Absolutely zero damage. I mean, they came right out. So that's how it should be. Okay. Desoldering done. And this board I don't even need to clean. So what I can do is just take my little brush and I will just brush this flux right into the through holes. And we'll clean the board up after we're done. Here we go. Now we got our through holes all fluxed up. We're ready to roll. And we take care of our gun. Clean. Ready for the next use. All right, I'll be back. And here we are after a good cleaning. Here's the all of those RAM. You can see the legs are really nice. Really cleans them up well. I got you looking through this magnifier. But yep, I just cleaned those with some Tarnex and then I washed the board as usual. So we'll go ahead and I'll fix this one trace that was broken. We'll repopulate everything. and we'll see where we're at, see what we got. All right, this board is put back together. We got nice new sockets. Our RAM are cleaned up. You can actually see the legs. Hopefully they're all good. That would be awesome. That would be really nice. They're Texas Instruments, so there's a good chance that they're all good. And the fact that there's no shorted to ground means that none of these are shorted to ground, so that might be good. Never know. I have, you can see down in here, you see the trace repair down there. It's all good to go. I cleaned this. I got under the microscope and looked in here. And when I looked through the microscope, there was quite a bit of green fuzzy in this thing. Fuzzy green stuff. So I sprayed it with vinegar, and I scrubbed it with a toothbrush, and rinsed it back out and dried it good. And then I looked under the microscope at it again, and it was nice and clean and shiny. So we cleaned that up really good. It was pretty fuzzy. You can't really see that by just looking at it. But get under the microscope and I can actually see it. Yeah, I got it nice and cleaned up. Yeah, so nice connector. Yeah, Midway used good ones in the early run of these 8080 sets. The early run of the 8080 sets, they used good connectors. Towards the end with the Space Invaders Deluxe and stuff, they use those cheap green ones. They're really cheap. But, yeah, we got our, we're soldered in nicely. That is not a short, that's just like crust. I'll give it another scrub. Yeah. Looks really good. One pad was missing right there. That was the only pad that was missing, but it didn't matter. It's soldered. Excellent. All right, so now I got to finish the other board. I got to do the sockets on the other board and clean it up, and we'll be ready to go. Okay, and I went ahead and did my strapping. I'll zoom in on it so you can kind of see how it's going to look. So this right here, let me get something here. Oh goodness, yeah, whatever. This is address bit 9, I believe, and this is actually +5 going to pin 21, and that's the only change. It was jumped 12 volts to here and then -5 to here. I removed those and put this one, pin 21, right to 5 volts, and address bit 10 maybe? I don't remember. I think it's address bit 10 you have to jump over to here. This is address bit 10, that's what it is. And that sends that to pin 19. That is the strapping. So this board just burned some ROMs and this thing will be ready to go. Put a CPU in it. Alright. Okay, and we are complete here now. Got the amps back in, new sockets underneath them. And I got heatsink paste grease to transfer heat better. I have deoxidized the pots. New sockets here, and I tested this 175 in my reader, and it tested no good. Not my reader, but my my little chip tester. And that thing's kind of flaky, so it might not be, but it said it was no good, so I put a new 175 in. Put these chips back in. So yeah. They're all squared away. And these guys are over here. This cap broke, so I put a new cap in right here, 0.1. Yeah. Alright, we're ready. We'll put this thing back together and give it a fire up. Well, I do have to burn ROMs. I got to burn EPROMs, and that's it. I got to put a CPU in it. The CPU's no good, but so burn EPROMs, put a CPU in it, and we'll fire it up. Okay, I had to do some strapping on right here, which I need to actually clean that up. So we will go over this and explain why I did what I did here. First thing we'll do is do a little cleanup. Let me get under here really quick and grab one of these, okay? Okay. Okay. So, what did I do here? This was jumped straight across here to here, here to here, and here to here. What they had was over here on the selector, the least significant bit was address bit 10. And the second bit was 11, and the third one was address 14, and the highest bit, the most significant bit, is grounded. The only one that I care about is address bit 11, really. Address bit 11, let me back this up. And now on the back side of this thing, on the back side of this, I just jumped. Let me zoom back in. On the back side, I just jumped these two. I solder blobbed these two together. And why I did that is because I want address bit 14 when ROMs are being selected from range 0 to FFF. You want all of that to be 0 over there. And I unhooked this, and if it's floating, it's just going to be a 1 and it's going to mess everything up. So I tied it to address bit 14, the third bit. I tied those together, so when that's 0, this will be 0. This is the only one I care about, is address bit 11. And I'll show you why. Let's back up. Okay, I burnt the ROMs. And those two ROMs are in these ranges. 0 to 7FF and 800 to FFF. 0 to 7FF and 800 to FFF. And if we look over here, I've just kind of got some notes of how it was. It was the least significant bit was address bit 10. And then the second bit was 11. And then the next one was 14. And then grounded, the most significant bit. So I was just kind of doing some notes here. And if the 10th bit, which is right here, is on that selector, when this turns to a 1 at address 400, it's going to switch ROMs. It's going to switch which ROM that it is accessing. So I did not want that to determine anything. I want this from here down to not matter. So you basically had to take that strapping off of that and move it up to 11, and then 11. This one was 10 and 11. Then move 11 anywhere. 11 didn't matter. That's why I just tied it, that one, to 14, so that when this is all 0, that'll be 0 as well. This is the only one I cared about. But I couldn't unhook this one though and just leave it floating, because then that would be a 1 right here. So that would mess up whenever it went to 100. It would always be 100 basically. It'd always be messing up the selection of the ROMs. Sorry for shaking the table. So I had to have that tied to the next bit, so when that's 0, they're both 0, so it doesn't interfere what's going on right here. So I've got that all squared away. That's ready to go. I got my ROMs programmed and in the board, and we're ready to hook up to this thing. All right. After I had the Fluke hooked up to this thing, and I discovered that we had a bad address bit. It was telling me address bit 10 was bad, and address bit 10 is bad. This chip, address bit 10, is buffered through this 08, and it was tied low. So we are now removing that 08 and replacing it. It was this chip right here. I just cut it out of the board, and we'll do it this way. I don't know where that went. It's hard to see recording like this. Oh. There we go. There we go. And I'll grab my solder over here. I'm just going to put a little new solder into here. Make desoldering a little easier. Okay. Go ahead and spin this around. Make sure we're on this okay. Yeah, it's right here. And we'll just use the old solder sucker thing. do it. You know, this one might need to be cleared out a little bit better. Maybe. It's hard to tell. Can't tell too well. I think that's better. Okay. Oops. Yeah, that looks pretty good. That'll work. That'll work. So let me go grab a socket. 14-pin socket. Let me try to adjust this a little bit. Yeah. Okay. This is right here. You know what? Let's do this. I'm going to put this down here and then kind of there we go. Look right through that glass. That way we can share the glass, the magnifier. Actually, I'm not even really looking through the magnifier because okay. I'm going to be right in the way, aren't I? Yeah, I'll try to do this. Yep, I'm sorry. I'm sorry, guys. I can't film this like this. I'm going to back this up a little bit. And I'm going to go ahead and solder this because I have to be able to see what I'm doing. And I can't see what I'm doing like that. Okay, here we go. We got our new socket in. Give it a nice little clean. Good enough. Okay, let's Let's get this soldering iron out of here. We're good with that. Okay. And I'm going to go away and I'll be right back. Put everything back together and I'll be right back. Alright, I've been pulling my hair out over address bit 10. Address bit 10 is causing me all kinds of trouble because it looks like it's floating. It's just going crazy like this. And I followed it down to here. I followed it down to this chip here. I cut that chip out of the board, no change. I figured, well, maybe that's keeping it, you know, to a low. It's almost low, but it's kind of floating. That's not it. It can't be anything else. It comes over here and it goes to here, you know, address bit 9 or address bit 10. And then I got to looking at actually up here. You know, I tested, made sure, okay, I'm not shorting anything. Address bit 10 in these early Space Invaders boards, pin 19 is normally pulled low or pulled high, and or something, or it's negative 5 volts. That's what it is. It's normally plus 12, actually. I think one of these, it's plus 12, I believe. Here, I'll figure out right now. This plus 12. Yep. It's normally plus 12 with these old EPROMs. So I removed plus 12 over here, and I moved it to address bit 19 to send, or address bit 10. Put address bit 10 over here, and it's like floating. And I'm pulling my hair out. I can't figure out why. And then I started, you know, I checked and made sure there was no shorts here. And then I seen these caps and I was like, well, I wonder. Pin 19, which was 12 volts on the older EPROMs, they were tri-volt EPROMs, so that was the 12 volt pin. The 12 volts was being filtered by these caps. These caps are filtering my address bit 10. So as address bit 10 is going square wave, these caps are filtering it. That's why it looks like it's floating. I got to remove, I'm just going to cut these right out of the board. I'm not even going to bother removing them. I'm just going to cut them right out. And that'll fix address bit 10. I don't want that address bit line to be filtered. Well, that one went flying. Yeah, address bit 10 was being filtered by those caps. Now it's not being filtered. So now I'll go ahead and hook this back up. And I am going to have to replace this. But anyway, I just want to hook it up and look at address bit 10. And I'm sure that removing those filtering caps is going to fix it. I'm sure of it. And I'll put the cap back on it because it won't run. It won't do anything if you put the CPU in it, because I don't have the that chip in there. So we'll go ahead and I'm just going to fire up my fluke. Turn this thing on. And this thing has to, I do have to clean this because it doesn't want to, I have to mess with that to get my fluke to work. Okay. I'm just going to read at FFFF. I just want this bit to toggle. Oops. Okay, and let's check address 10, and now it's a square wave. Now it's working. Address bit 10 is working. There. It was being filtered. So I'm going to go ahead and do a ROM read 7FF, and that should be 082E. A82E. Yeah. It it didn't dawn on me because I didn't bother checking what those caps were doing, and that my ROM was okay. And now I'll do the second one. And that is 432E. 432E. Yeah, so if you're doing this and you're changing to this kind of EPROMs and you're putting address bit 10 onto pin 19, you need to cut those caps out of the board because they'll filter your address bit 10. And that ROM's okay. So my ROMs are good now. I'm reading ROMs. I'll replace that LS 157 that I cut out of the board tomorrow. I'm going to go ahead and shut down. I'm going to run to the dollar store tomorrow too because I need to buy. I'm just going to buy an eraser, a big eraser to clean the edge of this card off, because it doesn't really need to be. It's pretty nice. It just needs to be clean, you know. Oh, that's my Space Invaders one. That's not even the right one. This one here just needs to be cleaned with an eraser pretty good, and it should be fine. So this thing will probably work, I'm hoping, after we replace this chip tomorrow. I'm going to go ahead and replace this guy tomorrow, and then I'll do RAM checks and make sure my RAMs are all good. But my ROMs are good. I'm reading ROMs great. Yeah, that was pretty funny though. I was sitting there, I'm like, why in the world? I couldn't figure out why address bit 10 was floating. My signals coming in from the CPU looked great, but the output on this was floating, and it was because that line, address bit 10, was being filtered by these little caps up here. Yep, those little caps that were in the board right up in here were filtering that line. So I figured it out. It took a minute to figure out, but as soon as I realized it, and I was doing some beeping out, and I beeped that out, and then I took my probe and I beeped on those caps, and I was like, it's connected to the caps. The caps are filtering it. So yeah. Okay. Well, we'll be back tomorrow. We'll replace this chip and see where we're at. All right. I'm doing a RAM short right now from 2003 FFF. And it's about to be done-ish. It's working. But we do have one bad RAM. It's this one right here. You can see I have it jumped. If I can get in on that, you can see I have a RAM jumped over right here. Yeah. That one right there is jumped over. But we just had it finish as okay. And if I go ahead and remove this and try the same thing, let me grab the camera so that I can actually just show you what's going on. Okay, I just removed this where I had it jumped, and we'll show you. Let me show you. Let me repeat this. And it'll fail once it gets up to around 38A0. Address 38A0 or 3A80 or something like that. It'll fail, and it'll say read write error bits 10. Yep. 3A80. So one of these RAMs has bad cells starting right there. And if I hit continue, it's every even address. You'll see 38A4, 6, 8, 10, 12, 14, and then back to 0. 2, 4, 6, 8, 10, 12, 14, back to 0, or 2. I skipped one. Might have had a good cell. Yeah, see, it's got some good cells. But most of them are bad. And if I loop that, bit 10. Now, I know on this hardware that it goes bits 0, 1, 2, 3, 4, 5, 6, 7. Obviously, now I know that this is the even addresses and this is the odd addresses, because it's telling me bit 10 is bad, right? 10. That would be, according how the fluke is telling you, is this is the first 4 bits, so these are all good. 0, 0 bad. And on the second 4 bits, it's telling you bit 1 out of this 4 is bad. So here's 1, 2, 4, 8. The 1's bit, 2's bit, 4's bit, 8 bit. See, if it said 80, that would have been this one. But it said 10, so it's this one. And these are the even addresses, these are the odd addresses. So this RAM right here is no good. And that's the one I had jumped over. So I'll go ahead and replace this guy right here. And come back. And by the way, while I'm waiting for my gun to heat up to remove that RAM, I removed these 2 sockets. I had put 4 sockets in here. I removed the 2 because I'm going to keep them, because I use a lot of sockets, so why leave them in the board if they're not being used? So I removed them, and then I filled the empty holes, I filled back in with solder. And I covered this trace repair. That was that trace repair I did. I covered that with urethane. And yeah, so. So I'm just waiting for that. We'll remove that RAM. And when I did, after I did remove these, I verified that these were good with the fluke. Again, make sure I didn't have anything going on there. So, yep. Excellent. This is a nice looking board. Nice and clean. Okay, we got our new RAM in the board. And my last 22-pin RAM socket. So I'm going to have to order me some sockets. And we are running the UUT. And it is working. It does have graphics glitches. And I can tell you right now, That is the 25S10. Is that what it is? 25S10? It's a shift register problem. So this thing, I'm thinking it's most likely a bad shift register. So what I'm going to do is put the plates on this thing, plate that up on the sides so that I can flip it over and get to that backboard, and we will look at those shift registers. I'm pretty sure that's what it is. That's the same, my previous Gunfight repair, it's the same symptoms. Like the white picket fence covering the gunman. That was those shift registers. But it's running. It's working. We got to test the sounds yet and everything, but I imagine the sounds will probably be okay. Well, look, first things first, let's get the graphics right, and then we can move on to testing sounds. And the good news is those shift registers, they're all socketed. I could actually just replace them and do that and find out which one's the bad one. It could be a connection between the boards too. I still have to clean that connector. It's still not a great connection. I need to go to the dollar store and buy a big eraser so that I can just clean that off. So I'm going to do that. Before I go testing any parts, I'm going to make sure I got a good connection on that edge connector. So, but yeah, this is promising. We're just about there. The main board is good to go. Our main board is now fixed. So I can actually put the fluke up. I don't even need it no more. So that's plan of attack. I'm going to go ahead, put the fluke away, and I'm going to run to the dollar store and grab a big industrial type eraser so that I can use it to clean off those that plated edge connector on that backboard. And I'll be back. Alright, I have this thing all bracketed up. And I just, instead of taking the time and analyzing everything, I just did swap-a-roos. And I came up with, this is the bad chip. So, yeah, these three are okay. But we still have a little line through our guy. Some lines. So there's still something that's not quite right. See that? I don't know. See the little lines through them? Yeah. So they're still a little goofy. So we'll go ahead and start looking at some stuff. Something on here is just slightly not right. And I mean just slightly. So, all right, I'm going to have to start looking at it. No more lines through the guy. It turned out to be this 175 right there. It was just a case of which one doesn't fit. The outputs were stuck. One of them was stuck high. I believe one was stuck low. It just wasn't toggling. So it was an easy find on the 175 right there. And I know those 175s supply signals to these 25S10 shift registers. And so I was just going through and looking at the outputs, and they're complementary. It has a Q and a not Q, so they have complementary outputs. And one of them, this one right here, one of the outputs would toggle, the Q output would toggle, but the not Q one was stuck low. So I knew that one wasn't working right. So I was like, well, that's probably my problem. So I just went ahead and replaced it, and that was it. So it was one bad 175 and one bad shift register. And now we can move on to test sound. Okay. Caps have all been replaced on this backboard. This board right here. All those caps have been replaced. And it did vastly improve the sound volume. Problem is, that one works. That one don't. See that? It's this bottom one that isn't working right. So I'm going to actually swap the amps and see if it follows. I actually hope it's not a bad amp, because those TDA 1004s are not cheap, you know, and they're kind of rare. So I'm going to try the amp. It's probably a bad amp. It's this one underneath the bottom. I don't know. I really think it's the amp. See that? This is the top side. This is the bottom. It's tinny. That's a bad amp, I guarantee it. So I'm going to take it apart and try a new amp. Okay, I have just removed this amp. That's the one that was in question. I took the one that was in the top and I moved it to the bottom. And now if I fire this guy, see? So the circuitry is good, the amp is bad. This is a TAA621, which I can get on eBay, but from China for like $7, $10 shipping or something like that. So, yeah, interesting. But I'm going to have to buy one of these. There's no way around it. This thing is bad. So this one's going to get put on hold and put aside. We've got everything capped really nice, which is good. I just have to I have to buy a new amp. So this thing is done other than that. So I'm going to just call it good. I'm going to end this one right here because that's just elementary. It's just buying an amp. I'll have to use my heat gun probably. If it doesn't come with this bar, I'll have to use my heat gun to heat this up and remove this from this bar. And then I'll attach the bar to this because that threads through there, remember? And then I'll put some adhesive, some thermal adhesive on the bar, and then when I put the heatsink on, it'll adhere to the chip. Either that or I could just put heat paste. You know, I don't have to have that glued on there really. But that's how I'm going to have to go about it. So I'll go ahead and put in an order from China for one of those. I'll probably buy a few of them actually. And yeah, nicely recapped. Our board is redone and fixed. So I'll probably turn this off. I'll probably remove this amp because I don't want to run this really a long time. It's not even hot. But I don't want to run it without that big heat sink on it, even though it probably doesn't matter. And I'll do the burn test. I'll run this thing for 3 hours without the amps. I mean, it doesn't really matter. I'm just testing and making sure all the other circuitry is good. So, yeah. That's it. We will see you on the next one, guys. Gunfight. All right, bye for now. See you next time. Partner. See you next time, partner.